All right. So today we are going to be solving systems of equations, but now instead of having two variables, today we're going to have three variables. But it's nothing really different, nothing new from what we did yesterday. So if you understood yesterday's lesson, it's going to be fairly easy to do today's lesson. It's just doing the same thing just more times. All right, so here we go. Yesterday, I'm going to give you an idea of what we're going to do. There's an overview of it. Yesterday, we started with an equation, yes? And it had how many variables in it? 2. We started with another equation, and it had how many variables in it? 2. And then we somehow combined those to make a new equation that only had how many variables? We took two equations, we combined them together, either substituting it or eliminating it, made a new equation that only had one variable in it. Yes? We got what x was. What did we then do with that? So we took and we went back to this one, we substituted it back in or plugged it in, and now we were able to find what y equaled. Yes? That was the overall idea of it. Okay? Hang with me. Today, I'm going to give you an equation that's going to have three variables. You don't have to write this, we're just talking over the concept. I'm going to give you another equation that's going to have three variables. And I'm going to have another equation that has three variables. By the way, if you had two variables, how many equations did we have to have? If we have three variables, we have to have. If we have four, we would have to have, which we won't go into, but and so on and so forth. It gets into matrices later on. There are things that have 5 variables. You have to have 5 equations, and then they don't solve it this way. They have a thing that's called a matrix that you do in a much higher level class. I think I did 4. I don't remember if I ever did 5. But it's matrices are actually kind of almost like a Sudoku kind of thing. They're kind of different. They're a little weird. But anyways, here's the problem with this. I have 3 equations that have 3 variables. What I'm going to do is I'm going to somehow combine 2 of these to make an equation that has 2 variables. The variables here might be x, y, and z. Over here, depending on what I cancel out, it can change, but maybe I have y and z only left over. Does that kind of make sense? Now, I'm either going to combine this one and this one, or this one and this one. One of those options, and we're going to talk about, why I choose the option I choose, and we're going to create a second equation that only has 2 variables. What 2 variables do we need to make sure we are only left with? Y and z. The 2 that whatever 2 we were left with up in the first one, we have to make sure that those are the same 2 that we are left here. So if we canceled out x the first time, when we create this new one, we're going to cancel out x again. Because then we're going to use these 2 variables like we did last night. These 2 equations, this turns into your question that you did last night, where you have 2 variables, 2 equations, combine them to get the 1 variable. Once I find, let's say this is, well, it can't be x because we canceled x out a while ago. Let's say this is z that we found. We would then come back in here and plug in, and we'd find y. We would then plug in z and y over here, and we'd find x. That's the overall gist of this, what we're going to do. It's not any harder. It's the same concept over and over again. So here we go. Let's do a problem. Now you can start writing. Remember with this, there was never one that was necessarily the right way, but there were ways that were smarter than the other ways. So this is equation 1, this is equation 2, and this is equation 3. Again, not necessarily that one way is better, like not right, but there are better ways to combine this. Right away, what could I combine? That would cancel something out really easy without having to do too much work. If I did 1 and 2, I could cancel out z. Yes? If I used 1 and 2 equations and I added them together, a negative z and a positive z would cancel out. What would that mean I'd be left with? X and y, yes? So then I would have to come up with some combination since I combined these first. I would have to come up with some combination of 1 and 3 together or 2 and 3 together. Good. She said 2 and 3, but no, I can't do 2 and 3 necessarily because the x, she was trying to cancel the x out. Remember, if I cancel the z out first, the next option I have to cancel z out again. Yep, that'd be fine. Do you guys understand what she just said? Oh yeah. That's okay. Each one of these is its own individual equation. So if I multiply just one of them by 2, say, that's fine. Do you guys understand what we just said or no? You need to ask me a question. That's what I'm trying to tell you. It doesn't matter. No one, that's why and I gave an example of football. I don't think you were here. You know how like when you get older, you have option routes? And depending on the way the defense is playing, there's a better route to run. That's what we have here. We have options here. We don't have to cancel that. Baby school, we said, this is how you solve math every single time. High school math, it gets, hey, you can do whichever one. Now, there are smarter ones, and that's what I'm trying to, it's my whole day today is explaining why I'm doing it the way I do it. Not that the other ways are wrong, but my way is probably easier and less room for error. So you can cancel out either the x's or the z's. Now, let's look at this. If we cancel the z out, does everybody understand? 1 and 2, the z's would cancel out. Yes? That would cancel out. Then I would have to come up with some combination of 1 and 3 or 2 and 3 to cancel the z out again. Do you follow me? Now, if I did 1 and 3, what would I have to multiply by so that 1 would cancel out with 3?
3.
3. Why would I have to multiply by 3? Because I need, this is a positive 3z. This is just a 1z. I'd have to multiply it by 3, so it becomes a 3z. Then they would cancel out. Yes? Now, why? So why would I probably pick this one and not this one? Why is it? It's a little bit harder. Why is it a little bit harder? Yes, because this is a positive z, and this is a positive z. So not only would I have to multiply it by 3, but I'd have to multiply it by a negative 3, which again opens me up for more error. Do you follow me? Do you guys want to cancel out the z's since we've already talked through it, or do you want to cancel out the x's? You want to cancel out the z's? By the way, if I wanted to cancel out the x's, do you see the x's would cancel out by 2 and 3 combining? Hello? And then what else would I do? Hey, stay with me. I know, stay with me. I'm talking you through this. No, I need it here. 1 and 2. Why would we do 1 and 2? Because one's positive, one is negative. So if I was doing the x's, I would personally combine 2 and 3 and 1 and 2 to make my new equations. All right, so we're going to do z's. That's what you guys said. I think in all my other classes I did x's. I know. So here we go. Let's combine. We said 1 and 2. 2x plus y minus z equals a negative 10. A negative x plus, I haven't combined them yet. This is the first equation. This is the second equation. I'm going to add these two equations together because when I do that, boom, I get x plus 3y equals negative 7. Now I've created one equation that only has how many variables? Two variables. I have one equation that has two variables. What did we say? When we have two variables, how many equations do we have to have in order to solve it? So I only have one right now. So I need to create another one. Do you follow me? So that's why I'm going to use 1 and 3 to create a second one. Yes, not by 2. No, by 3. I need to multiply this by 3, everything in it, so that it becomes a negative 3x or 3z. So it becomes 6x plus 3y minus 3z equals negative 30. Did everybody follow me on that? And then this becomes a x plus 2y plus 3z equals 13. Combine like stuff, these cancel out. 7x, bless you, plus 5y equals, and when you combine that, that becomes a what? Negative 17? Yes? Negative 30 in there, number 1. Ooh, I don't like this one. That's a negative 30. Getting rid of the x's made it easier in the beginning. So right here is from last night's. I have two now equations with two variables. I can do substitution or elimination. I prefer elimination. So I'm going to do elimination. Remember, watch the videos from last night. I'm going to do elimination, but technically, I think you said it. You could just minus the 3y and make it say x equals, and then you could do substitution. I don't like substitution. It's just my personal preference. Oh my goodness, that's the smallest ratio ever. So I am actually going to do elimination. I like it better. What do I have to do though to make one of these eliminate? He said, hey, if I times this whole thing by negative 7, boom, this becomes a negative 7x minus 21y equals a positive 49. And then I have a 7x plus 5y equals negative 17. Yes? Cancel this out. This becomes a negative 16y equals, and that becomes the 32. Divide by negative 16, divide by negative 16, and y equals negative 2. Okay. You start to get in the swing of it, it gets better. The goal is to find x, y, and z, right? By the way, they go in order, and they do matter, right? Say your alphabet, what comes first? So x, y, and z is how this is going to be written. So which one did we find? Which is where? Yeah, the middle one. Okay, hold on. Hey, what did we just find? we still need to find x and z, correct? Okay, now I don't want to come back up here yet, because how many variables do these things have in them? If I plug in y, I still have 2 variables. I still can't get it, right? So I need to find a place that only has 2 variables that has a y located in it. Do you see right here? By the way, I could use that one. I could use this one. I could use any of them that just have how many variables? 2 variables, as long as it has the y, yes? You could use them. Yeah, you could use, as long as it only has 2 variables in it, but you only use one of them. You only need to use one of them because you're just trying to solve for x now. So I'm going to use this one because it's x. Do you see, why did I choose this one? Why is it easier? It's because the x is all by itself here. That's why. Because if I did this one, I would eventually have to divide by 7. Not that it's hard. I don't know yet. X plus 3 times -2 equals -7. That's a 3. Sorry, this thing's acting all screwy on me right now. X minus 6 equals -7. Add 6, add 6. X equals -1. Yeah. Don't let that screw you up. I've had a lot of kids. So x is -1. Now what do I have to do? So I'm going to use one of these up here. Personally, I would probably use this one. Why would I use the middle one? No, because the z is by itself and it's not negative. Because remember, that's what I'm trying to find. I don't care about the x and the y because those are going to be numbers. I'm trying to get the z, so I pick what one I think is the easiest z to find. Could I use the top one? Yes. Could I use the bottom one? Yes. Any 3 of these would work. I'm just trying to show you why I'm picking the one I did. So what's the middle equation again? So negative. Now I plug in that. Remember, if it's -x, that's what it would look like. And why does that matter? What happens when I have a negative and negative? What does it kick to? So this is a positive one, so be careful. So it's -x what? So plus 2 times what was y? Plus z equals 3. So this turns into a +2 and a -2 turns into a -4. Yes. -3 plus z equals 3. Add 3. Add 3. Z equals 6. So it's -1, -2, 6. That's my answer. Not if you understand it. Not if you get the concept of what we're trying to do. Did that make sense? Online, did that make sense? Questions online or in class? You will have these to do on the test. Not many. All right. So I